On a night in May 2024, pink and green light poured over places that almost never see it. Thousands of miles apart. The same night. Millions of people stood in the dark, photographing the most beautiful night of the decade. But in a handful of quiet control rooms, no one was looking up. They were looking at screens. Because the storm that painted the sky that night was a warning shot. They always are. We watch it now. Every hour. At every temperature it burns. Our star has done something far worse than this before, and we know, because the trees wrote it down. September 1st, 1859. An English astronomer named Richard Carrington was sketching sunspots through his telescope when 2 points of blinding white light flared on the surface of our star. 17 hours later, the sky over Earth erupted. Auroras burned as far south as Cuba. In the Rocky Mountains, the light was so bright that miners woke after midnight and started making breakfast, convinced it was morning. And then the technology of the age began to fail. Telegraph lines sparked. Operators were shocked at their keys. Some offices disconnected their batteries and found their machines still running, powered by the storm itself. It was the strongest solar storm in recorded history. And for a century and a half, we told ourselves that was the ceiling, the worst our star could do. We were wrong, and the proof wasn't hiding in space. It was standing in the forests the whole time. In 2012, a Japanese physicist named Fusa Miyake was studying something almost no one else thought to look at: the rings of ancient cedar trees. Here is the secret written into every tree on Earth. High-energy particles from space strike our atmosphere and create a rare form of carbon, carbon-14. Trees breathe it in. And because a tree grows exactly 1 ring a year, every ring is a page in a diary, a record of the sky, kept in wood. Most pages say the same thing: quiet, quiet, quiet. Then Miyake reached the ring for the year 774, and the diary screamed. A spike of radiocarbon, roughly 20 times larger than normal year-to-year variation. She checked other trees. Same year. Same spike. Then other countries. Then other continents. Cedars in Japan. Oaks in Europe. Every tree alive in 774, anywhere on Earth, had recorded the same violent year. Something struck this entire planet from space. And the most likely culprit, the explanation that has survived a decade of challenges, is a solar particle storm estimated at tens of times stronger than anything in the era of instruments. Perhaps more. Even its upper limit is still being argued. In the Anglo-Saxon Chronicle, a scribe recorded a red crucifix in the sky after sunset. Whether he saw this storm, historians still debate. The trees, however, do not debate. They simply remember. Once scientists knew what to look for, the diary gave up its other pages. Other years, the sky had screamed. The year 993. Then, far deeper in the past, 660 before Christ. Thousands of years before that, another. And around 9,000 years ago, perhaps the most violent of them all. About half a dozen confirmed events in the last 14,000 years, with more still being found. And here is the detail that matters. There is no pattern. no rhythm. The calendar of fire does not announce its next entry. But this record is not only a warning, it is also a gift. The spike from the year 993 was carried in every tree alive at the time, including the wood that Norse explorers cut when they landed in North America. So scientists counted the rings from that mark outward to the day the tree was cut, and it told them the exact year the Vikings arrived. 1021. A 1,000-year-old storm had become a perfect clock. So the record is real. The storms are real, which leaves the question that should keep you up at night. What happens if the next ring forms this year? We don't have to imagine it. Our star has already been sending us smaller warnings for decades. March 1989. A storm, far weaker than Carrington, hit the power grid of Quebec in Canada, and the world was watching.
6 million people across Quebec woke up to darkness and disbelief. For the second time in less than a year, the entire province had been hit by a power failure. People at Hydro-Quebec are not positive, but they think the blackout was caused by the sun.
The grid collapsed in 90 seconds. 6 million people woke up in the dark. It lasted 9 hours. February 2022. A small storm warmed the upper air and made it swell. And dozens of newly launched Starlink satellites fell out of the sky. And then there is the one almost nobody talks about. July 2012. Our star fired a storm as strong as Carrington, straight through Earth's orbit. It crossed the exact path our planet travels. We had passed that spot just 9 days earlier. 9 days. That was the width of the miss. A direct hit today would hit the one thing everything else depends on: the power grid. The giant transformers that run it are custom built. Each one takes months to replace, sometimes years. Flights grounded, GPS gone dark. One study put the cost for the United States alone at up to $2.5 trillion. Another asked a darker question. What happens to the cables under the ocean, the ones that carry the internet? The honest answer is that we have never tested any of this against the real thing. And remember, all of that is just a Carrington. The storm in the trees was many times stronger. Now, this is where every other video stops, with the fear. But the strangest part of this story isn't fear. It's what scientists found when they stopped studying our own sun and pointed a telescope at thousands of other stars. For 4 years, the Kepler Space Telescope stared at one patch of sky. And in that patch, scientists picked out 56,000 stars. Stars like ours. Same size, same heat, same kind of star. Now, think about what that means. Watching 56,000 suns for 4 years is the same as watching one sun for 220,000 years. And in all that starlight, they counted nearly 3,000 superflares. Explosions releasing more energy than 1 trillion hydrogen bombs. Do the math, and you get a number that changed everything. A star like ours fires a superflare about once every 100 years. And these giant flares look just like our own sun's small ones, only far bigger. Same physics, which means our sun has the same engine. Now, the honest part, because this channel doesn't deal in panic, our own tree rings tell a gentler story. The truly extreme storms hit us far less often, maybe once, in 1,000 years. So maybe our sun is a quiet one. Or maybe we have just been lucky. Scientists genuinely disagree, and that argument is the frontier. But here is the detail almost nobody mentions. Our sun runs on an 11-year cycle. The peak of that cycle ended in late 2024. We are past it now. That sounds like safety. History says otherwise. Every one of the great storms of the last 2 cycles came after the peak, which means the danger is not behind us. It is in front. So what stands between us and the next ring in the trees? For the first time in the history of this planet, a watch. Satellites stare at our sun around the clock. And 1,000,000 miles from Earth, spacecraft sit and wait, directly in the path of the solar wind. When a storm passes them, we get a final warning. Minutes to an hour. A big eruption takes longer to cross space. That gives us 15 hours, sometimes 3 days. And one probe, named Parker, has flown through the sun's outer atmosphere itself. The first human object to touch a star. But a warning is not a shield. Radiation from a flare arrives in minutes. For that, there is nothing to do. But for the great eruptions, hours matter. Power companies can switch off the grid before the storm hits and save it. Planes can turn back. Satellites can shut down and ride it out. The plan is not to stop the storm. No one can. The plan is to see it coming and be ready. Somewhere, right now, a tree is growing. A Japanese cedar, an alpine pine, an oak at the edge of a field. This year's ring is forming. Thin, quiet, ordinary. But someday, one of those rings will not be ordinary. It will carry the same mark, the mark of 774. Centuries from now, a scientist will count backward through the wood and find our year written in the diary.